All right, so section 1.5, pictures. Now, I talked a little bit about this in the beginning of the semester. With today's technology, anyone is capable of generating extremely attractive, three-dimensional, full-color graphs with Excel by pushing a button. So I used to teach a lot of different methods of graphing the data, and I don't anymore because it really doesn't require any intelligence to do that. So I narrowed it down to two, and I explained this early in the semester why I do this. You can do this anywhere with just a pen and a piece of paper, assuming that you meet certain requirements for the data. And what if you happen to be sitting next to someone in a subway, and the person that you're doing some consulting for, and they give you some data, and you just want to have a rough idea of what the data looks like? You will run into this occasionally where you might have to just roughly get an idea of the data. And this is what we're going to do today. So we're going to learn two different ways of doing this with very simple by-hand techniques. So what does the blob look like? We are going to use stem and leaf plot and box plot. All right. Now, stem and leaf plot can come in handy also if you travel a lot. Anyone been to Japan before? No. Amazing country. You got to go there if you haven't been there. All the train signs for train departures in the stations in Japan are stem and leaf plots. If you can't read a stem and leaf plot, you will have no idea what time those trains are coming or what time the trains are leaving. This is the train schedule, and it's a stem and leaf plot. So we're going to go over how to do a stem and leaf plot first, then we'll come back and look at the train sign. So a stem and leaf plot is a method of presenting data in a graphical format to reveal the distribution of the data. A lot of what we are doing this semester requires our data to be bell-shaped. If it's not, some of the stuff that we're learning, we cannot do on it. So what are you going to do? Take my Stat 2 class, Econ 222. And that's what we are actually doing this semester. Before this class is we have been doing how to deal with that. So you might want to get an idea if it looks somewhat like a bell, so you know how to approach what you're going to be doing to the data. All right. So let me show you on the board first how to do this, because the data that's in our example is a little more challenging than the data I'm going to use. So let's say we had these numbers. Okay, so let's say we had these numbers: 6, 11, 12, 15, 18, 22, 24, and 33. So these are my numbers. And I need to do a stem and leaf plot for these. So a stem and leaf plot it's only practical if we have to do by hand if we have a small number of pieces of data. If you have like 1,000 pieces of data, you're not going to be doing this by hand. All right, so to do a stem and leaf plot, the first thing we need is to have all these digits, all these numbers have the same number of digits. So all of them have 2 except this one. So we have to come up with a creative way of making this into 2 digits and yet not change the number. And we do that by putting a 0 in front of it. If we put the 0 after it, then it becomes 60, right? If I put a bunch of zeros here, it's still 6. Okay. Now, in the case of 2-digit numbers, where we only have 2 numbers, the first and the last number in each of these. The first is the stem, the second is the leaf. Or you can think of it as a branch in a leaf. So my stems are 0, 1, we have a bunch of 1s, 2, we have a couple 2s, and a 3. So I'm going to write those stems down vertically. So 0, 1, 2, and 3. And then I draw a line. Now I put all the leaves that are on these branches or on these stems. So my 0 branch has a number 6 leaf on it. So I put that here. And that's it. There's no more 0 branches. The 1 branch has a bunch of leaves. It has a 1, it has a 2, it has a 5, and it has an 8. My 2 has a 2 and a 4 for leaves. And my 3 has a 3 for a leaf. Great. Then you take your head and you do this. And you can see that this is positively skewed. So it looks like that. Now, yes, it is very low resolution, and but it is somewhat bell-shaped, but it is slightly skewed. So this way, you can just get an overall idea of what the data looks like. Now, the interesting thing about stem and leaf plot is this: what if your dog eats all your original data? If you have this, you can reconstruct the original data set. It's one of the only graphs you can do that with. 6, 11, 12, 15, 18, 22, 24, and 33. So you can actually construct that. Now, this was a common question in the past when I give a take-home exams or an in-class exam or whatever. I would give the students stem and leaf plot and say, construct the original data from it. So you should be able to go both directions fairly easily with this. So this is a very simple stem and leaf plot. Now let's look at one that's a little more challenging. Okay, so here's my example of one that's a little more challenging. So these are my red fox tracks for the front foot length again. Now in this case, they're all 3 digits, so I don't have to change them at all. Now, because we have 3 digits instead of 2, a leaf, in this case, is just going to be 1 digit, which is the last digit up here. The stems are going to be the first 2 digits. So I have some 2.2s, I have a few 2.3s, and I have a couple 2.4s. So I list out 2.2, 2.3, and 2.4, and then I attach the leaves that are on these. So my 2.2, I have a 0 leaf, and a 5 leaf, and a 5 leaf. 0, 5, and 5. For my 2.3s, I have a 0, a 0, a 5, and a 5 for leaves. And 2.4, I have 2 zeros down there. All right. If you're doing this by hand, one thing that's really important is make sure these numbers are all the same size and the same spacing, right? If you wrote like big 0, 5, and 5, and then wrote 0, 5, 5, 5, 5 really small for the next one, it's not going to tell you anything. So make sure your numbers are nice straight columns so that you get an idea of what this distribution looks like. This doesn't really tell us a whole heck of a lot of anything because it's pretty small. All right, so this is how you stem and leaf. So let's look at that sign again. Zoom in on this side. So if you look at this, this train leaves from this terminal at 5:10, 5:17, 5:29, 5:39. This is military time, so this would be noon. This would be 1 o'clock. I can't see that. 1:09, 1:11, 1:15, 1:19, 1:24, and so on. So that is when the trains leave this specific platform. All right, so stem and leaf. So if you're going to go to Japan, 2 things. 1, know how to do this. And 2, know that when you go into Starbucks and you see a croissant in the display case and it looks like it has a layer of chocolate in it, it's really pate, and it's not the best thing to eat in the morning. Because I made that mistake when I thought it was chocolate. And they also don't have the venti size anything there. It's they eliminated our venti size and they just have the grande, the tall, and then something smaller than the tall. And if you really want an interesting treat, go to a McDonald's. Because it is the fanciest McDonald's you'll ever be in. You can't even, they don't let you take your garbage back. It's like full service tables. They'll come pick up your garbage for you. There's lots of bowing going on when you're ordering. It's a very unique experience. The uniforms are all pressed perfectly, and you know, it looks like you went into like some high-end jewelry store in America. That's what the employees all look like. Very clean, very pressed, not a hair out of place, no talking whatsoever unless you're ordering something. Very unique experience.